Hi, my name is Payne. I'm from 4B KG Section 3. I'm going to present my final year project 1. My title is Predicting the Dielectric Characteristic of Transformer Insulating Oil Under Certain Conditions based on DOE theory. What is transformer oil? Transformer oil is used to provide the protection on the paper insulation and to act as a cooling agent in the transformer. And it also used for preventing the arcing shocks and the corona discharges in the transformer. What is the dielectric characteristic in transformer oil? It is the characteristic that can prevent the charges in the transformer move freely, which can keep the electricity from flowing in the unwanted spaces within the transformer. It also can prevent the corona discharges and arcing shocks happen in transformer oil. So, what are the failures that may occur in transformer because of the changes in dielectric characteristic? There are winding failures, bushing failures, core failures, and tank failures. Now, let's talk about the problem statement of this project. The transformer insulating oil commonly used is crude oil. Crude oil has low flash point and it is not eco-friendly due to its limited biodegradability. And second, traditional experiment method consumes a lot of time in testing and analyzing the results. Traditional experiment method requires more cost due to many repetitions of testing. The motivation of this project is due to the limitations of using mineral oil. FR3 natural ester oil is suggested to be used as the transformer insulating oil. This is because FR3 natural ester oil is derived from renewable vegetable oil, which is more eco-friendly compared to crude oil. FR3 natural ester oil also contains higher resistance towards high temperature. Design of experiment DOE is suggested to use in this project because it is less time consuming and easier to be analyzed. The objectives of this project are to investigate the properties of different types of transformer oil under different conditions. Second, to study the factors on the dielectric characteristic of transformer insulating oil under different conditions by using DOE method. Lastly, to evaluate the performances and responses of different types of insulating oil under different conditions. The insulating materials that used in transformer are papers and oils. They're using paper because of its pure cellulose, which gives excellent electrical properties. The cellulose is a good insulator and it is polarity, so that it provides a dielectric constant. Next, the oil used in transformer insulating system. Next, the oil used in transformer insulating system is mineral oil, natural ester oil, and rapeseed oil. There are two types of mineral oil that used in transformer insulating system. There are naphtha oil and paraffin oil. Naphtha oil are more easily to be oxidized compared to paraffin oil, but the precipitation formed during the oxidation of naphtha oil are more soluble compared to paraffin oil, so that the precipitation won't affect the cooling system of transformer. But for paraffin oil, the precipitation will be stick to the bottom of the tank, so the cooling system of the transformer will be affected. Next is FR3 natural ester oil. It is formed by soybean base and more biodegradable and non-toxic to the environment. And because of its non-corrosive properties, it has ability to protect the transformer insulating system 5 to 8 times more than mineral oil. And it has higher fresh point than mineral oil, and it also can draw out, retain moisture, and absorb water driven off by aging paper. And lastly is rapeseed oil. Rapeseed oil is kind of the vegetable oil that used for cooking purpose. It is more safety and more biodegradable compared to mineral oil. And because of it can withstand higher temperature than mineral oil, so that it can provide long lifespan to the transformer insulating system. The conditions that affect the dielectric characteristic. First is temperature. The temperature may cause the aging process of the transformer. This is because if the transformer's temperature increases, the amount of waters migrate from the paper to the oil will be increased. And this will lower down the breakdown voltage of the insulating system. And this also will cause failures in transformer. Next is acidity. The acidity is caused by the oxidation of the transformer oil with the water, and it will cause the acidity of the oil increases. Next is moisture. The moisture slowly soaks the insulation paper as the transformer oil ages. A soft insulation paper on transformer windings will decrease the insulation and also the transformer functionality and efficiency. And when the temperature in the transformer has increases, and this very soft paper will release again the water into the transformer oil. And this will cause oxidation that can increases the amount of acid and water. And this will bring failures to the transformer also. The fourth conditions that may affect the dielectric characteristic is dielectric strength. The dielectric strength shows the maximum breakdown voltage and the maximum impulse voltage that the transformer insulating system can withstand. The first dielectric characteristics test that I want to introduce is moisture content test. This is to test the moisture content in the insulation paper. The effects of the moisture content in transformer insulation system are decreasing the dielectric strength and accelerating cellulose decomposition of the insulation paper and increasing the risk of bubble formation at high temperatures. And the moisture inside will also condense during the cool down. The factors that produce the moisture content in the transformer oil is the residual moisture and the moisture from the atmosphere and through poor seals by the flow of moist air and during the installation or repair, and also the water formed as the paper insulation ages. From the research, the water saturation limits of the natural ester is higher than the one in mineral oil. And because of its hygroscopic effect, natural water remains in liquid form instead of migrating to solid insulation, which extends the life of the solid insulation. Hygroscopic effect is the phenomenon of attracting and holding water molecules via either absorption or adsorption from the surrounding environment, which is usually at normal or room temperature. By comparing the moisture content in rapeseed oil and mineral oil, the moisture content in vegetable oil is higher than the one in mineral oil, and this will cause the dielectric strength being decreased because of the conductivity of the transformer oil is increased. Next is breakdown voltage test. This test is to test the dielectric strength of the transformer oil. The breakdown voltage of an insulator is the minimum voltage that causes a portion of an insulator to become electrically conductive. The factors that may affect the breakdown voltage: the moisture content and the temperature. So, the lower the breakdown voltage, the more the impurities in the transformer oil. From a research, the mean breakdown voltage of a mineral oil is 181 kV, but for FR3 natural ester oil is 159 kV. But for the lowest breakdown voltage, the mineral oil have 114 kV, while FR3 natural ester oil have 149 kV. And the third dielectric characteristics test is dissolved gas analysis. This analysis is to check the internal health of the transformer. Whenever a transformer undergoes abnormal thermal and electrical stresses, certain gases are produced due to the decomposition of the transformer oil. The gases found in the oil in service are hydrogen, methane, ethane, ethylene, acetylene, carbon monoxide, carbon dioxide, nitrogen, and oxygen gas. And from the research, it says that generally it is found that hydrogen and methane are produced in large quantity if the internal temperature of power transformer rises up to 150 degrees Celsius to 300 degrees Celsius due to the abnormal thermal stresses. If the temperature goes above 300 degrees Celsius, ethylene C2H4 is produced in large quantity. If the temperature is higher than 700 Celsius, a large amount of hydrogen gas and ethylene are produced. The presence of ethylene shows that there are very high temperature inside the transformer. If during TGA tests for transformer oil, carbon monoxide and carbon dioxide are found in large quantity, and it is predicted that there is decomposition of proper insulation. The first test is breakdown voltage test. For the test 1 is to test the breakdown voltage under various temperature. Apparatus are breakdown voltage tester and thermostat, and the materials for it are mineral oil, FR3 natural ester oil, and rapeseed oil. And for the test 2 is to test the breakdown voltage under different moisture content. Apparatus are breakdown voltage tester and syringe. The materials will be mineral oil, FR3 natural oil, rapeseed oil, and water. For the second test is dissolved gas analysis. Choose the sampling of oil from the transformer. take the extraction of the gases from the oil based on different temperatures, do the analysis of the extracted gas mixture in a gas chromatography, do the interpretation of the analysis according to an evaluation scheme. Here are the procedure of gas chromatography. Step 1. Sample injection and vaporization. A small amount of liquid sample to be analyzed is drawn up into a syringe. The syringe needle is positioned in the hot injection port of the gas chromatograph and the sample is injected quickly. The injection of the sample is considered to be a point in time. That is, it is assumed that the entire sample enters the gas chromatograph at the same time, so the sample must be injected quickly. The temperature is set to be higher than the boiling points of the components of the mixture so that the components will vaporize. The vaporized components then mix with the inert gas mobile phase to be carried to the gas chromatography column to be separated. Step 2. Separation in the column. Components in the mixture are separated based on their abilities to adsorb on or by to the stationary phase. A component that adsorbs more strongly to the stationary phase will spend the most time in the column, which means that it has the longest retention time and it will emerge from the gas chromatograph last. And a component that adsorbs the least strongly to the stationary phase will spend the least time in the column, which means that it has the shortest retention time and it will emerge from the gas chromatograph first. Last, detecting and recording results. The components of the mixture reach the detector at different times due to differences in the time they are retained in the column. The component that is retained the shortest time in the column is detected first, and the component that is retained the longest time in the column is detected last. The detector sends a signal to the chart recorder, which results in a peak on the chart paper. The component that is detected first is recorded first. The component that is detected last is recorded last. The expected result for breakdown voltage test. For test 1, mineral oil has highest breakdown voltage even at high temperature because mineral oil has higher resistance of high temperature with compared to Fr3 natural ester oil and rapeseed oil. For test 2, Fr3 natural ester oil has highest breakdown voltage even though it has higher moisture content than mineral oil, while almost the same with rapeseed oil, but it has hygroscopic that can draw the retained moisture and absorb the water contents in the paper. For the expected result for dissolved gas analysis, CH4 and C2H4 do not largely exist in Fr3 natural ester oil and rapeseed oil when the temperature is over 300 degrees Celsius. Fr3 and rapeseed oil generate a significant amount of C2H6. Rapeseed oil generate a significant amount of H2. The main dissolved gas for Fr3 oil is C2H6 and the main dissolved gas in rapeseed oil are C2H6 and H2, while for mineral oil is CH4.